All right, topic for today, what consumes the disk space the most? And yeah, this is quite a favorite topic of mine, so I can really elaborate on it. And during like every maintenance working with customer instances, this question a lot of bothers me. So let's have a look on the topic. What is the agenda for this presentation? We will a little bit debunk what kind of things are involved. And of course, we have a database, we have tables inside the database, we have data types like strings or just characters or numbers, decimals, and stuff. And yeah, and in the on the top of the presentation, we will learn a technique how to see what kind of items are fulfilling the database the most, and also a different type of query can show what kind of hosts are consuming the most database space inside your instance. All right. Let's jump into the tables. In the modern Zabbix instance, or in every Zabbix instance, we always have more than 100 tables. And here currently on screen, these are the titles which are consuming the most disk space. On the left side, history table, it's storing integers. Sorry, no, historical table is storing decimal numbers. The next one, history underscore u int is storing integers, and in the middle, this is mainly we will talk about in upcoming slides. String, it's a table where the value can reach up to 128 characters. Text table, one value can reach up to 64 kilobytes, like there will be 65,000 characters in one value. That's quite big metric. And log table is having the same length as the text value, and it's 65,000 characters for one metric. That's quite a big metric. And of course, events sometimes can also consume a little bit more database space if you have a very huge installation, more than 10,000 of hosts, and maybe you are using global correlation, then events table will also fulfill a little bit more, but not so much as we can actually fulfill the text and log table. All right, here, like the very basic warm-up SQL statement, and don't worry if you want to, if you're worried where you can get this presentation, this content will be published in our official Zabbix blog tomorrow. So don't worry, right now I will entertain you and explain how it works. So this query is to list the biggest tables for the most popular database engine, most likely MySQL. Just run the query, make sure the database is as you have it configured for the backend or the front end. And here's in the output, it shows the table, history uint, text uint, and the size 3 GB, and 0. For the MySQL, sorry, for the Postgres, we are also having the technique how to list that. Here's the query, and in case if you're having right now very modern installation by running the timescale DB extension enabled, then this query will actually list what are the biggest hypertables, not the tables. So it will be a little bit more seconds to look on the output to understand what's there, because hypertable is like a chunk for month or one day. There will be a lot of lines inside the output. And now here, maybe you don't like to gather inside the to work with the command line and all this thing with the SQL or SSH session. Just right before I will jump into the deep analysis, let's remind ourselves that there are still built-in techniques how we can a little bit track what kind of information is coming to the instance. And there are built-in items, Zabbix internal items, and inside the template Zabbix app, template app Zabbix server, we do have already a lot of internal items, but not these ones. These ones I made it like as additional items. You can modify your template here. This is the built-in name for the 5.0 instance. And these items will measure what is like the current input for one of the data type. Here again, string, log, decimal number, integers, and text. And here, this is like a 6-second interval in my lab, but usually we can have 30 seconds or 1 minute, and it will indicate inside the graph if there is some increase happening. And sometimes if some proxy goes down maybe and it goes back again, it will start to push instantly some information. You will see some different act here. Or maybe you're collecting a log, you are monitoring a log file, you are capturing the keyword error, everything is normal usually, but when the error occurs, there will be some increase happening, and you can understand which data table currently is having an increase. Going further, starting to analyze data, and this first query suitable for MySQL. And what we are doing, we are analyzing one of the big tables, history log in the example. And we are analyzing the data from last 30 minutes. And we are measuring how many values per one host did arrive, like count of metrics. And in the same time, what's the average length of the metric, like how many characters the metric weight. And here in the output is a count, 400, average size, almost 100 characters per one metric. And to have some number for the indication, I'm just having a mathematical function, count times average. And this is the number to sort the output from the SQL. And it pinpoints that this host is a VMware host, and we are collecting the content using the VMware event log item. And yeah, for the last 30 minutes, it has been collected like 44,000 characters. It's like nothing in this context. And this query is analyzing only the log table. You really have to replace this keyword history underscore log with the history underscore text and history underscore string to really measure all the places where the data gets inserted. It does not matter. It does not like really indicate that this VMware host is currently destroying the instance. Let's say in that way, you have to also analyze all the tables where the data is, where the other data goes in. Okay, and here currently on screen, it's this very same query as in the previous slide. And sometimes at first we can really see the metric right in the SQL client. And to do that, we can just, you see here the item ID, and we run this statement, select value from history log. We are having history log table where item ID is the number and limit 1. And you will see a sample of the metric. And you can see on screen exactly what kind of information you are collecting in the database and you are storing in the database. And if in case if this number is like huge, maybe 1 billion or something, then you can maybe think that you made a mistake by configuring this item. It's collecting too much useless information, and you can remove it from the database right away. Here, the command how to do it on the SQL, and at the beginning of the command is like set session SQL log bin, like turn off the bin log. Otherwise, this delete statement will actually fulfill the disk more than before. If there is like maybe millions of entries to delete, it will like add few megabytes to the disk, and And actually, this query, if you drop the first part, it will actually fulfill more disk space than before, because in MySQL, when you delete entries inside the table, it does not really free up the space inside the disk. It only cleans the rows, and you end up having a table with empty rows, but the disk space has not been changed. We will learn in upcoming slides how to face this problem. Okay, and here the query you all wanted, I guess, and you can make a selfie on it if you don't want to wait till tomorrow. And what it does, it will show the statistics per one host. It will analyze here in example history underscore text table, and give you a view which host is storing the most information inside this table, exactly in this history table. And I'm going like here are like time constraints, and I'm analyzing not current data, but let's say yesterday's data. And I'm doing that before. Sometimes we tend to keep some items for like historical period 1 hour, and then the housekeeper maybe deletes the content. And that's the reason why I'm analyzing here the yesterday's partition, and I'm analyzing the scale of 6 minutes. That's like very tiny interval, but just because this query is very heavy, it can crash your database server if you do not have enough memory. So please start with a 6 minutes interval, because it will aggregate absolute every host which you have, and every host which stores some information inside this table. It will do the aggregation. It will measure what's the disk consumption. And here in the output, finally, we have some host titles, like Java Gateway is having, for the interval of 6 minutes, Java Gateway is having 2,000 of 2,400 lines, and the size of this is like nothing in this example, but almost 1 megabyte. If you succeed this query like with the interval of 1 minute, that's quite good time, then you can just add a 0, like analyze 60 minutes. It will be 1 hour. If that executes relatively fast, increase more. Let's have 600 minutes, and you will see the statistics in the output. And again, here to see, just because this is analyzing the text table, you have to reproduce the very same query with the history underscore log, history underscore string. And please do not do by hand. Use some replace operation inside the Notepad++. Just replace this pattern with a different pattern. Okay, let's continue. Now we will look really on the file system. In the MySQL, when we use InnoDB per table, and it's recommended way to approach like to have the database server running with the MySQL with the InnoDB per table on. It means that each table in database will have a separate file inside the file system. And it's quite standard nowadays, like in the last 10 years, all the database engines from the MySQL is using this approach by default. And here you can at first locate what's the data directory for the MySQL engine, what's the directory for the database itself, and then you can exit the MySQL client and navigate to this directory and see what's the size on the file system. What's the size on file system? And in the situation where when you use database table partition, the database table partitioning, there will be like an output like such, history underscore log, hashtag partition, hashtag, and then the name of the partition. And here we can see like the year 2021 second week partition size is 44 megabytes. And third week is consuming 30 megabytes. And in upcoming slide, we will learn a SQL statement, a SQL query to analyze exactly a partition. And don't be excited like you see here in the output, a very big partition. Don't jump to the biggest partition just because you are keen to see what's consuming the space there. Just because that the analyze operation is very heavily, I really suggest to start with the smallest one to see if it works okay in a relatively good time frame. So here, two options we have: 44 megabytes or 13 megabytes. And then here in the one technique by using MySQL, how we can ask the same query: what hosts are consuming the most disk space for the interval of the partition name. And again, it will answer the most consuming space is VMware host for the partition, which is like second week of the year. And this host standalone like consumes 20 megabytes. And you can instantly understand if you like delete this host in Zabbix, then you will gain a lot of benefits, or maybe you just need to shrink the items or reconfigure how the items are collecting data. Okay. Finally, as I mentioned before, when we delete entries inside the table, it does not free up space on the MySQL database engine. And to actually free up space, we need to rebuild a partition. And the command for that is alter table history rebuild partition, and then the name of the partition. And the first command is just to see what are the options for the partition name if you have enabled it already. Don't run this command on the instance where you do not have partitioning on the MySQL. It will log the table. It will kill the instance. All right. On the Postgres, there is a little bit different story. If we delete entries inside the Zabbix database, which runs behind the Postgres, let's say for the beginning, it will shrink the tables because the Postgres has built-in functionality. It's called Autovacuum. It's like a tiny worker service which will vacuum the dead tuples inside the table. And the tuple is something similar like an empty row, and it will grab those empty rows out, and it will be much smaller table, and you will actually have more disk space while using Postgres. But the thing is, once you grow your infrastructure, you can encounter an issue that this worker does not do the job anymore, because there is like a definition. The default definition is very safe, and it says to clear these dead tuples on certain conditions. But if the instance is very overloaded, to not overload it even more, it will stop doing this task. And to ensure the vacuuming is happening on the Postgres, we have to run this query, and it will output all the tables or hyper tables which has some sort of dead tuples. This is quite a big example. So number live tuples, it's like billion of rows here. And this column are indicating the badness. So more like a big number of rows are dead. And the last Autovacuum has been executed like months ago. So that's the reason why the disk is not freeing up automatically, just because the instance is huge. So a solution for that is to install a bit higher definition for the Postgres engine for this Autovacuum worker to be more energetic on cleaning up those empty rows. Okay. Some tips how to build a much more healthier instance. And as this presentation is oriented to the collecting some textual data, and we do have a log file monitoring available inside the Zabbix, and it's we have an application, we collect a log file, and it works fine. That's okay. And sometimes we configure these log files to capture any line which contains a keyword error, and that's quite okay if you just learning the ways how the application works. But really suggested way to be later on to use this log.count item. This is an item which allows to count the patterns on the fly in the level of Zabbix agent. So agent will do the hard work, will count the errors, and agent will report the number to the server, like integer number. And you can save a lot of disk space by using this approach. And the golden line to summarize this approach is that when you invent a monitoring for the new application, you will have one log item which will capture all the errors, and then you will over time you will create these tiny log count items. Each log count item is capturing one specific error code, and two benefits is happening here. You can represent the occurrence inside the graph, and you can save a lot of disk space. And once you always create this log count item, you just need to exclude this pattern to be collected from the original item, which is used to learn about the application, what kind of error codes it can generate. And the last slide, I guess, Zabbix raw items. When we have an official templates available in Zabbix, and those templates most likely are using bulk requests, which means that we open a connection, we gather information. This information consists with multiple lines. We close the connection, and then at the server side, we fill so-called dependable items just to give them the integers they want. So these dependable items want numbers, and at the end we drop the original item, and these original items are called Zabbix raw items, and by default the history is 0, and that's cool. It's like everything is good. Sometimes for the troubleshooting purposes we can enable history here 1 hour or something, and we can see what's the original input, and we can debug the situation. And if you will miss this setting back history 1 hour to 0, then yeah, it will fulfill the database. And just because if the instance has database table partitioning, then this interval 1 hour will be overwritten by 90 days by default, and you will store everything for 90 days, and that's bad. So this is a problem. All right, that's it for my presentation. Thank you for having me. Questions?
Yes, thank you a lot. And we do have a couple of questions. So let's see, which one should I throw at you first? All right, from your personal experience, currently, would you use housekeeping or would you use partitioning with drop partitions?
I guess not partitioning. You can save a lot of disk space by not using partitioning. And the deal breaker most likely is if you are very precise what kind of metrics you want to collect, then don't use partitioning. And this will allow always to keep some metrics for 2 weeks, some metrics for 3 months, some metrics for 2 days. So you gain this benefit to keep always only what's necessary. You can save a lot of disk space, and you will a little bit sacrifice the load of the database server. Me personally, I have disabled the housekeeper during the day and create a cron job to execute manually it during the night when I do not browse the instance.
Mm-hmm. But I think, and I think you would agree on that, on some really large instances that maybe are limited by their hardware,
Yes.
at some point, then maybe partitioning is a good option.
I will say the threshold maybe 200 hosts or 500 hosts. Once you have 1,000 hosts, then partitioning is a must.
And regarding the second part of the question about improving Housekeeper, I haven't heard of any plans. Maybe it's probably under the hood. Performance improvements are always under the hood. But I'm not sure if there's anything kind of officially announced yet. But I think we're constantly improving the housekeeping performance as we move along.
Yeah, that's true.
And timescale, right? Timescale does partitioning out of the box.
Yes.
Okay. Does Zabbix Housekeeper handle the Autovacuum on Postgres, or do you need to configure it manually?
Autovacuum is like at the database side. It's not related to Zabbix application at all.
So you need to configure it on your own and run it.
And it's by default running on a small instance, I'm pretty sure.
I think it maybe depends on the version, because I have seen some use cases where it has been disabled, but yeah, need to take care of that on your own. Let's see. Okay, do you maybe have an instance where the master item does not have a historical period of 0? And what would be a use case for that?
Quite interesting question. Maybe not in the production, only when while you are developing a template, maybe a huge one, when you need to always see the data, then it's too time consuming to enable the historical period for the raw item once the problem has occurred. You need to keep it always alive. So when you encounter some issues and you think that there must be some improvements inside the template, then that would be the use case we have historical data for our item.
All right, since we are short on time, I won't be able to ask you the other questions, but feel free to take a look at the Q&A section.